Hello everyone, it's Red Saber here from Saber C++, and today we're going to be learning about how to use an RFID reader with RFID tags. Let's get started. This is our RFID reader, which sends out electromagnetic signals that interact with a tag, like this one, or a key card, to cause the tag to return its unique ID to the RFID sensor, which the RFID sensor can then use to determine, say, if the tag is valid to open a door. Now, most of these RFID kits, including the one I've linked to in the description, come with a keycard and or a keychain tag like this. But you can also use a hotel keycard like this one, as they operate using the same technology. The first thing we need to do is provide power to the RFID reader. I'll start by connecting a red wire from the 3.3 volt pin on the RFID reader to the 3.3 volt pin on the Arduino. Make sure you use the 3.3 volt pin on the Arduino or you may fry your RFID reader. We'll also need to connect the RFID reader's ground pin to one of the Arduino's ground pins. And I'll connect this green wire from the RST pin on the sensor, short for reset, to pin 5 on the Arduino. Next, I'll connect this blue wire from the MISO pin on the reader to port 12 on the Arduino. Then I'll connect this purple wire from the MOSI pin to port 11 on the Arduino. And then this orange wire from the SCK pin on the reader to port 13 on the Arduino. And lastly, a green wire from the SDA pin on the sensor to port 11 on the Arduino. That's all the wiring. Now let's get on the computer and write our program. First, we'll need to download a library, which holds a lot of code that will make it easier for us to interface with the RFID sensor. First, I'll go over to the library manager, which is this little stack of books here. And then I'll type in the name of the library, which is MFRC522. As you can see, it's the first option here, so I'll just install. The first program we're going to write will simply print out the values of the cards or tags the RFID reader is able to read. Once we know the values of our tags, we can use that to write a program that will check the tags and determine if it should open a door or something like that. I'll start by including the two libraries we'll need. The first is spi.h, and the second is the one we just downloaded, MFRC522.h. Then I'll define a couple of constants to hold the ports we connected the reader to. The first one will be called SDA pin, and I'll set it to 10, and the second one will be called RST pin, short for reset pin, and we'll set it to 5. Now we need to create an object of type MFRC522, which is our RFID sensor, and we'll name it RFID. We'll need to construct this from the values of the SDA pin and the reset pin, which we just defined. In the setup function, let's start by initializing serial communication using serial.begin and putting in the baud rate, in this case 9600. Then we'll initialize SPI using SPI.begin because we're going to be communicating with our RFID sensor using SPI. Lastly, we'll initialize the RFID sensor by calling rfid.pcd_init. Now that everything is set up, let's add some code in the loop function that will read any cards or tags and print it out. First, we'll check if RFID.PICC is new card present. This basically checks if a new card has entered the range of the RFID sensor, which means that we won't keep printing out the value of the card if a card stays within the range for a long period of time. We also want to check if RFID.PICC read card serial, which basically just checks if we're actually able to read the value from the card. And if we can, it reads it. To print the UID off the card or tag, we'll need to turn it from an array of bytes into a string. First, let's create a string variable called tag and set it to an empty string using a pair of double quotes. Then we'll use a for loop going from 0 all the way up to the size of the byte array, which is held in rfid.uid.size. Inside of the for loop, we'll add a string to the tag, and this string will be a space, and then now we'll need to create a new string object to turn this from a byte into a string. So we'll get the rfid.uid.uid byte at the current index, and we'll turn it into a string using this string constructor that we just created here. So now we'll have a string called tag that contains each of the bytes in the rfid.uid separated by spaces. Then we'll want to print out this information. So first, we'll print out UID, and then we'll print out the tag. The last thing we need to do is tell the RFID reader to leave this tag alone and go back to scanning for more using RFID.PICC_HALT-A and RFID.PCD_StopCrypto1. Let's try it out. As you can see, we're now printing out the value of the tag or card when they come inside the reader's range. It looks like I'm getting this first number, F963F3B8, for the tag, and FCE2EB24 for my hotel keycard. Next, we're going to adjust the program so that we can check the value of the tag in the code to see if it matches a preset value. We could use this for something like a lock, where we only want a certain keycard to be able to open it. Before we do, if this video has been helpful to you so far, please give it a like so I can keep producing more. So, let's try checking the UID on the tag to see if it's the UID we have set up in our code. First, I'm going to go back up to the top and I'm going to create a string called UID, which I'll set to one of these UIDs. I'll just go ahead and choose the first one, which is the UID from the little blue tag. I'll paste that in, including the space at the beginning, and now we know what the UID that we want to allow in is. So after we print out the UID, I'll create another if statement, and we'll say if the tag dot equals, it's important that you use dot equals and not two equal signs when using strings, otherwise it won't work properly, UID. So if the tag is the same as the UID, then this tag is accepted. So let's print out a line saying accepted. Else, let's print out a line saying denied. Alright, let's try it out. And there we go. Now, when we move the keychain tag close to it, it prints out the F9 UID and accepts it. However, when we move the keycard close to it, it prints out this UID and denies it. If we wanted to connect this to a lock or something, we could simply open the lock inside this accepted if statement and refuse to open the lock when it's denied. If you'd like to learn about some other Arduino sensors and modules, check out my channel, Saber C++. Thanks for watching.